through a little bit of it last time. Fill in what you need to fill in on this set of notes. Lines, rays, and segments. When we name a line, array, or a segment, how many letters? Always two. Always two letters to name a line, array, or segment. All right? So they're all the same. So if I'm doing this, you got to know how to do this stuff. I got A, B. Somebody read that to me.
Line segment AB.
All right, so segment AB, line segment AB would work. Now what's it say? Ray AB. All right? Now what's it say? Line AB. Okay, so they're all three different, but they're all three sort of the same. Got to make sure you know the difference in the three. Make sure you're using the correct symbols. Two letters without a symbol tells you that you are measuring that thing. Can I measure a line? So can this be a line? Can I measure a ray? So it can't be a line, it can't be a ray. It's got to be a segment. Fill segment in right there in that spot. So when you see something and it looks like this, how can you read that to me? Somebody read this to me, and I want it complete so I know exactly, and everybody else knows exactly what it says. The first word that he said, very, very important, segment QR. Segment QR equals 12 centimeters. We got to know that that's a segment. All right? So when you don't see, I'll send you down in a second. I'll send you down in a second. Why would I send it to the office? Why are you trying to confuse me?
I'm sorry.
So you got to know that that's a segment and we can measure. Fill in whatever you need to fill in if you haven't already. John, they want you down in Miss Mike's
Since the guidance nowhere.
Between this. Trying to remember any names here. We got these three young men right here. What do we know about these three young men? They're collinear. They're all on the same line, right? They're collinear to each other. We can say that Jonathan is between Tage and... All right, tell me because I can't remember. Matt and Matt.
Hi, Mom.
Does everybody understand that? You're all right. That's what between means. Jonathan's between these two. Can we say that Chase is between Matt and Tage? Even though, as I walk by him, sort of between, right? But it doesn't work that way in geometry. In geometry, to be between, you have to be on the same line. You have to be collinear. This is just a little abbreviation here. Instead of writing out if and only if, a lot of times in math we just put IFF. So when I put that on something, don't say or don't think that I spelled it wrong. It's just a shortened way. We're going to draw this. Somebody help me out. If I'm drawing what they stated right here, what am I going to start with drawing? A line. Everybody agree with that? Sure. So on your paper there, draw a line.
So,
What else are we going to put on it? Point A and point B where?
Point A is a one equal line.
So like here,
Yes.
point A, label it.
And
On the other end is what?
C.
Point C.
But somewhere in between the two are
Somewhere in between is point B. Does it have to be right in the middle? Not necessarily. They didn't tell us all that. So I'll just put it somewhere like that. About 90% of what we're going to do today, it's going to be drawing it and then doing what I'm doing next. And that is this. This is what they're going to ask us to do. Using segment addition, we know that if I walk from A to B, and then I walk from B to C, I walked a total of what? A to C. That's all segment addition is. They're going to tell us something like, segment AB is 2x. And this is how I want you to label it, and how you're going to label it for the whole year. I put these little marks on here. Does everybody know what that sort of means? From this end to that end is how much? 2x. And if they tell us from B to C is x plus 7. Just going to fill it in that way. And then the other thing they might tell you is how long is segment AC. I don't know, make up a number for me. 30 what? 32? Right? We got to be able to draw this picture and label things with what they tell us this way. From that, can we set up an algebraic equation? What are you going to do with these two?
2x plus x plus 7.
We're going to add those together, so it's going to end up being like 2x plus x plus 7. What do we know about those two added together?
They make 3x. Well, they have to make 3x.
They add up to equal that whole thing. Did you learn how to solve equations like that last year? Hopefully. That's what we're going to do. Now, some of them is going to be a little easier than that, like this one right here. What do we do to figure out this whole length? What do you get? 17 centimeters. We filled that in last time? So that's, some of them are real easy. Some of them are a little more difficult. We're going to do this example together, then we're going to jump onto your computers. First example here. How am I going to find the length of segment TA? Everybody's favorite, right, Josh? Everybody loves fractions, don't they? You know? If, see, Jonathan's over here. Jonathan, get that calculator out so that if you have a calculator, it's dealing with these fractions going to be difficult. Use the ABC button on there. All right? I'm not one of these teachers that's going to say, put the calculator away and do it in your head. I don't care. Get it done. Get the answer. That's what I want. I don't care how you get it. Well, sort of I do. I don't want you to just sit there and wait till your neighbor gets done, then copy their answer. But use your calculator. What are we going to do with these two lengths? So 1 and 5/8 plus, if you don't have a calculator, then right there on your paper you should be writing down what I'm writing down so you can see how to do it. So you get that calculator. 2 and 3/4. Are fractions really all that difficult? They're just annoying because they take extra work and extra time. It's got nothing to do with them being hard. What do we got to do here to add these fractions? Find the common denominator. For 8 and 4, what will both of them go into? Everybody agree with that? 8 times what gives you 8? So if you multiply the bottom by 1, what do you got to multiply the top by? That one's pretty nice because it just stayed the same, right? On the bottom here, 4 times what gives you 8?
2.
Multiply the bottom by 2, you got to multiply the top by, what's that give you? Now we're just going to add. 5 plus 6 gives you what? Do I add 8 plus 8?
No.
The whole purpose of getting a common denominator was so we had something that stayed the same all the way through. So that stays as 8. If you need your neighbor to hold up a finger for you to do this, have them hold it up. 1 plus 2 is how much? 3. Jonathan, did you help Tage out and hold up that finger so he could count them? Didn't? Jonathan's looking at me like he's confused. Is that our answer?
No.
What do we do with that?
Improper fractions.
Got an improper fraction here. It's like you have more than a whole pie there, right? A whole pie is how much if we're dealing with 8? 8 out of 8. We want to take that over here, and when it comes over to the 3, it no longer stays 8 over 8. It now becomes a whole. And what's this 3 become?
4.
4, very good. If we take 8 out of 8 out of 11 out of 8, how much are we left with? How long is this whole segment? TA. 4 3/8 inches. Again, Jonathan, did you do it on your calculator? Was it pretty easy? Does everybody know how to do mixed numbers on their calculators if you have a calculator like this? If you have one of the big calculators, a little tougher. All right, I'm not going to explain that right now. If you have one of the big calculators, it's a little tougher. If you have this calculator, all you do to add these two, punch in 1 ABC button, 5 ABC button, 8 plus 2 ABC, 3 ABC, 4 ABC, and it ends up looking something like this. 4, and it's got like a little U. 3, got a slash, and then 8. All that means your whole number is 4, and this is your fraction. The big calculators, they're a little tougher. If you want me to explain those to you, I will at some point. I don't want to do it right this moment. Next thing I want you to do, get on your computers now. Now we're going to be on the computers. We are going to go back to those notes. You see all that space that you got down there below that last example? We're going to write a couple more examples in your notes. Kick you off already. You have to make that longer. My wife gets mad at me because my phone won't stay on because I don't know, I guess it tells me something good to sleep after like 5 seconds or something, and she gets mad because when I'm on the phone, I couldn't sleep. Make it longer. I said, well, go ahead and do it. I don't care about it. It's not bothering me. On your website. So you went to the website. Sorry, I forgot that I got to do this. You went to the website. Let's see if I can get to it. We don't want that. Something went right today. On your website. Let me get to the point where some of you probably are, and then we'll talk about it. Hopefully we don't have to do this every day. You're going to, after a couple times, you guys will understand how to get to each spot, right? What is my thing in? At first, you're someplace like this, only yours only has one book on it, right?
Yeah.
We're what class? So we click on Brown 3, we'll go to it. Then it looks like this. Does that look about the same? Go to course. We want to go to course. And it won't look like that. Mine's messed up because I've been messing with it all day long. And And when you go to course, it looks something like that. It says, welcome to reveal something, 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 right? Everybody with me to that point?
Mine went straight to
Yours went straight to the other stuff, because probably we already had it open at some point, so it jumped right back to where we left off, right? So you're probably ahead of us. Once you get to this point, you go to this little box. It looks something like that. Is that right? Does that look right? We want module 1, which is chapter 1. Once we're in the module, we click this box again. We're on lesson 3. Module 1, lesson 3. And then it looks something like that. Everybody find that page? Yes, no, maybe? Everybody with me? You're not there? Yep. Oh, yours is already clicked down, so. Next thing we want to do, click Explore and Develop. Then you should have a bunch of little boxes. Your boxes are smaller than my boxes, because my boxes have to be really big, because I'm old and I gotta be able to see them. All right? Chase is a little younger, so he can deal with the little bitty boxes. We want to go to, you guys are going to go to, we're going to work stuff on here. We're going to jump back to the notes here and there, and I'll tell you when to jump back to the notes, but a lot of them you're just going to work right here on this. You're going to go to example 1. Example 1. I'm going to go back to the PowerPoint because I have example 1 on my PowerPoint. You're going to do it on your computer. Did we already do it? Yeah. We'll do it again just to make sure. This will make you look smarter than you already have. So we're going to do it real quick. It's got little boxes on there. It's got these little boxes on there. Down at the bottom or something, they look like this. It says something plus something equals something, right? What do we put in this first box? 11.3. What do we put in the second box? 3.8. Then you push what? Check answer. Push check, and it says it's right. Let's go back and let's try this. Did it have to be 11.3 in this box? What else could it have been? Let's try it. I don't know. Try 3.8 plus 11.3, see if it still says you're right. It won't let you go back once you check your answer? No. Think we're right if we switch them around? Yeah, it should be. I don't know why it would be different. The only reason it'd be different is because the computer doesn't understand it, but it means the same thing. How long is this whole segment? 15 point what? 1. I think it tells you down there at the bottom, doesn't it? So again, segment addition postulate, this segment plus this segment should equal the whole thing. Next one, extra example 1. Close that out and go back, go to extra example 1. This one, I think they just gave you a box for the answer, right? Is that right? What do we got to do to find the answer to this one? So 7.4 plus 5.8. This segment plus this segment equals the entire thing. What did it come out to be? 14.2. Anybody agree with that? Punch it in there. 13.2. I don't know which one is it.
It's 13.
13.2. Which one? 13 or 14? 13. 13.2 is the correct answer.
Yeah.
Not your bad. I don't care. That's the whole point of this, right?
I care, because that was easy.
Nothing wrong with getting something wrong.
We make care of it, they don't do it.
Yeah, that's never a question. Ebersole don't care about much. Everybody understand that? Those are pretty easy, right? Whole bunch of the first part of the assignment, real simple like that. Next one, example 2. A little tougher, example 2. Go down and click on example 2. Example 2 is a little harder. How come? What's different? Right. This time, we have this segment plus this segment equals this whole thing. But they told them to us different. Instead of telling us the two small parts and us just adding to get the big part, now they told us the whole thing. How can we find QR here, segment QR? Again, is this going to be nice if you have a calculator to do this for you? Yeah. But if you don't, get one. What's the first thing we got to do before we can subtract with fractions?
We gotta get this number.
Common denominator. Let's do this quick. 8 again, right? 8, 8. 4 times what gives us 8? 2 times 3 is 6. What happens with this bottom? Nothing really hard about that, just extra work. We subtract. Remember, what are we doing? What's 6 minus 5? So we get 1/8 out there, that's a 1. 13 minus 6. And that was in what, feet? I think on yours, wasn't this a multiple choice or something? Oh, this one's a nothing. Is that the answer they came up with, was 7 and an 8? Everybody think they can handle that? Pretty easy. John, you handle that way back there? You lying to me? You figure it out. So let's figure it out on this one. Try this and try it on your own. Go to the next example, extra example 2. Try it. I think this one they give you multiple choice questions down there, right?
Yeah.
Or multiple choice answers. Yes, and see if you get it right. Let me show you how to do fractions on there. Yep. If you have one of the big calculators and you listen right now, I'll try to show you, I'll try to explain to you how to do fractions on it. It's not easy. The only real way that we can do it is you got to change all mixed numbers. Madison, you hearing all this? You got to change all mixed numbers into improper fractions. All right. So with the 12 and 5/8, we got to take 12 times the bottom number, which is 8, and then add 5 to it. So we do 12 times 8, it equals, and then add 5. And we get 101. So what that's telling us, you're going to have to help me out here in a second because I'm going to go through and record the right stuff. So what that's telling us is 12 and 5/8 is the same as 101 over 8. Okay? We got to do the same thing to this one. So we're going to take 3 times 8, it equals, add 7, and what do you get? So this is 31 over 8. All right? We want to do what with these two? Subtract them. So now we got 101 over 8 minus 31 over 8. on your calculators, the way you're going to punch that in, so that it gives you a fraction answer back, you're going to put it in parentheses. So you're going to put in parentheses 101 divided by 8, close the parenthesis, minus
It's just not making those work.
parenthesis 31 divided by 8, close the parenthesis. Then don't hit anything. Once you close that parenthesis, did you already hit it? Daggone you.
You can go back up to the
Yeah, you can. I think you hit like second and enter, and it'll go back up to the problem or something like that. Once you get to that point, now you're going to hit this button. There's a button on there that says math. Find the math button somewhere on your thing. See it? Push that.
Okay. That's a fraction.
Now, the very first thing it says is fraction. So you hit enter, and now it pops up on your screen. You had all this, and now it says fraction out next to it, and you hit enter again, and it's going to give your answer as a fraction. What's it say? 35 over 4. The bad thing with these calculators, the big calculators, they leave everything as an improper fraction. So now what we need to do is we need to change that into a mixed number. How many 4s are there in 35? 8. So that's our whole number. 8 times 4 is 32. So how many are left on top here? 3 4s. Is that one of the answers? Is that the correct answer?
Yes.
What I do, and this is just me because I'm really, really lazy, I love those big calculators, but guess what else I carry around with me? One of those little ones also, just because if I have to do something like that, it takes about 10 minutes on the big calculator, it takes about 30 seconds on the little calculator. That extra 9 minutes of my life is worth that $10 to spend on getting one of these little ones. So did everybody get 8 3/4 on that? What's 8 3/4? So this distance from X to Y, 8 3/4 feet. Does it make sense for that to be 8 3/4 feet? Yeah, it looks all right. 8 plus 3 is how much? 11. We said the whole thing was 12, a little more than 12. That makes sense. Give me a number that would not have made sense if we got the answer here.
13 and a half.
16 and a half. How come that wouldn't make sense? All right, so you're saying this part's 16 and a half, and the whole thing's only 12. That doesn't make a whole lot of sense. Example 3. Go off your computers and go back to your notes. In your notes, in that empty space right there, we're going to write this down. Take a second, write this sentence down in your notes. Right there where there was a big blank space that I left. Mr. Adler was yelling at me because I was wasting paper leaving all that space on there. Wasting the school's money. Again, while you're writing this down, intervention. During intervention, most every day, if you have any trouble, you get confused about anything, Come in. Sorry, I switched. Madison did it. You did too, I seen you.
Did not. I did nothing.
Madison wants to screw with everything. That's stuff up.
Did nothing.
If I'd be so happy about doing nothing. You said it like 5 times. Should be happy about doing nothing.
Well, I am doing nothing. Just
All
writing
right,
stuff
that
down.
sounds a little better. This is what most of the homework, and we're going to do these kind of problems all year long. What's the first thing we're going to do on this problem? For that. Draw it. You got to draw pictures in here. You got to draw that first assignment that we did. They had you do all those drawings, and a lot of them probably weren't real great, and you weren't real happy about doing them and everything. That's why. This is why they were having you do it. You have to draw stuff in here. Okay? Every time before I go to build something or I go to do something in my house, I draw it out. If you come around my house, my wife gets so mad because I have, see all this? This is like little lists and drawings of stuff that I'm doing at my house. I'm building her like a cabinet and stuff, and I got it all right here. And they lay on my kitchen table, and she gets annoyed because I lay everything on the kitchen table so I know where it's at. And then she moves it, and I say, well, I can't build your cabinet then because I don't know where my plans are. Got to draw something right away. How are we going to draw this? What's it explain to us?
B is between A and C.
So what do I need to draw? A line or a segment, correct? So let's draw a segment. And we know there's some point between two other points. What are we going to label those points? A first. What's next? The only one that really does matter is what? B has to be in between, right? So it doesn't matter if you switch the other two ends. Now, if we're doing this on the test, this is the way my tests work. I don't know how Ms. Barnes does hers. I don't know how Mr. Harrison does his. My tests are usually, a problem like this might be worth like 3 or 4 points. All right? You draw and label this, that's a point. How am I going to label this? I got that part. How else? What else did they tell us?
AC equals 4x.
So how am I going to show that on here?
Minus 2.
This is what I do. My son, my oldest son, has his architectural degree, and he does this all the time on his computer and stuff. This is how I do it, and this is how he showed me to do it. You draw these little bars that look like that. What's that telling you? From here to here is some certain distance. What are we putting in here for AC? 4x minus 12. What else did they tell us? So from A to B, drawing this in, is x. Right here to right there is x. Draw that in. If you get all that drawn on the test or quiz, that's a point. What do we do once we have all that? Sort of.
You got A, B, and BC.
So we know, just like those problems that we were just doing, they just had numbers in them. But we know, what do you do with this part and this part? Add them together, and they should equal what? the whole thing. So you just set up an equation. This plus this equals the whole thing. So what's the first thing I'm going to write down? X, that's our first segment. I hope everybody's getting this and not just Aaron. Is everybody getting it? Is this just easy and I should skip it and we should go on real quick? X plus, what else? 2x plus 3 equals 4x minus 12. Does everybody see all that? Too hard? Josh, too hard?
Nope. Not yet.
Now we're solving equations. I don't know how Mrs. Barnes taught you to solve equations, or Mr. Harrison, or anybody else. I didn't even know all that. I don't know how anybody else taught you to solve equations. It doesn't matter to me how you solve it, as long as you're getting to the correct answer. All right. I will give you some little tips along the way, because if I see Matt back here and he's solving these equations and he's always making some little mistake, then I'll give him a tip about it. A lot of you, the only reason that you have trouble solving equations, you have trouble reading your own writing. All right? So make sure as you're doing this, I look at Chase's, that's pretty good. Most of the time, I look around and I see somebody solving the equation and they can't read their own writing or they mix up the steps. Yes? Yeah, real quick. That's the way I'd like it to happen all the time, but I mean that's. Yeah. I don't think she ought to double up. All right, thank you. Gotta do it for you. Got it already?
Yeah,
Slow down, slow down. Way ahead of me. So, we go to solve this. Tell me the first thing we do. Combine like terms. Get it if they're on, and I draw the fence in. You don't have to draw the fence in. That's up to you. I draw the fence in, so I know that's the left side, that's the right side, and I can keep the two separate. And it makes my writing a little neater as I go through. What's the x and 2x give us?
3x.
That stays the same. Notice as I'm writing this, my writing's horrible, but can you read this? Yeah, because I take my time when I do this. What's the next thing we do?
Minus 3x.
Minus 3x. Very good.
I subtract 4x.
Now, it doesn't matter which way you take them, but one tip I will give you is I see a lot of students who want to get the 3 and the 12 together first. Get the variables together first, because otherwise it gets confusing sometimes. So if I minus 3x, and if you said you did it the other way, it's not going to make any difference. What's left here?
3 equals 1x minus 12.
And you add 12 to both sides. Add 12 to both sides. I'm ahead of myself. These cancel out. What's left on this side? 1x or just x, right? 3 plus 12. Is that our answer?
Yeah.
Go back and read the problem.
Oh, and
Please, please, please be very careful in geometry and algebra. You get to that point, and what was the case? You're done. Geometry, probably not. Sometimes yes, but a lot of times no. They're going to want you to do something else with that number. What do we know once we have x equals 15?
we know
So we could go back and do what? Plug it in. they're asking us to find x, which we already did, and the length of segment BC. So we're going to put what in place of that x right there? So 2 times 15 plus. This one's not very hard, but on some of them, if Madison grabs her calculator, if you have a calculator like you're supposed to have next week and you grab your calculator, you can type that into your calculator just like that, and it'll do it all for you. 2 parentheses, 15 parentheses, plus 3, and it does all the work. All right? Matt, you don't want to ever make anything easy on yourself, right? So you'd want to do it out long game, right? All right. So make it as easy as possible. What is 2 times 15 plus 3?
33.
So how long is segment BC? 33. How long is segment AB? 15. How long is segment AC? 48. Could we have found all of them if they'd asked us to find them all? Yeah. This time they didn't. They just asked us for this and this. Extra example 3. Write this one right below and try it on your paper there. It's not something that I'm going to check or anything, so just write it somewhere else. I don't care. Scrap paper or something. Just try it. This is all for your benefit. It's not. It's not like I'm going to walk around and check your notes and say, "You got the wrong answer on that one." I just want to see that you're doing something. See that you're trying, putting in some effort. Top of your screen is yellow. Why is that? You made it yellow?
Yeah.
Oh. How do you manage that?
You can put
That's already on. Because I never do anything else. Just curious. I never pay that much attention to that make the other, but it just looks weird. Is this one a little harder? How do you know? You didn't even try it. You're sitting there. Do it. What do we need to do first? Is it a little harder? Let's draw it. Let's see. What do we know?
that y is between x and z.
So what am I going to put on this point right here?
Y.
Here?
X.
Here? Either way, works out fine, right? Now what?
That x, y, bring
So from X to Y, 19, draw in something like that, shows that that's 19. Is that confusing anybody the way I draw that?
that should make
That makes sense? Matt looked at you like you were an idiot, Aaron, so I don't know. Matt, does it make sense to you that way? Alright. I'm just kidding. He looked at you like he didn't like you answering for him or something. So. What else they tell us?
X to z, no, y to z is equal to 2x plus 5.
So Y to Z, that's here to here. 2x plus 5.
Yes, 2x plus 5.
Alright. Then what?
And then x to z is equal to 6x plus 12.
So here to there. 6x. Oh, I think that's supposed to be a plus, isn't it?
That's
My fault. That's what was confusing you. Yeah, that would confuse it. Ebersole better write that down. fix, extra, example 3. That'll probably be the only typo you see me make all year long. 6x plus 12. Right now, again, if this was on the test, might be worth 4 points. You got what? Just for doing this much. 1 out of 4. 25%. Alright? Your second point's going to come from setting up your equation.
So it would be
What equation can I set up?
19 plus 2x plus 5 equals 6x plus
Slow down,
12.
slow down. Does everybody agree with Keaton so far? 19 plus 2x plus 5.
Yeah.
This plus that should equal what, Keaton?
6x plus
6x plus 12. Everybody with me to that point?
12.
Jalen, are you back on track?
Yes.
Be on track the whole time if Ebersole wouldn't screw up with you. What do I do first? 19 and 5 give me 24 plus 2x equals 6x plus 12. Something else I want to say when I go back to this. 19 plus 5, and I had not a whole lot of people answering. I'm hoping it's because you're working. But about half of you got a calculator laying right there. And if I ask you, hey, what's 19 plus 5? And you got a calculator laying right there, and you just look at me and look at me and look at me and try to figure out in your head, grab the daggone calculator and do it. Alright? You don't get any extra points for doing it in your head. Grab the calculator and make sure you get it right. Now what?
Then you subtract 12. That's what I got.
Now, is it alright to do the numbers first?
Yes.
Yeah, but just because I've been teaching for so long, I know if you do the numbers first, sometimes it screws you up.
Right. 2x.
So let's do the x's. Always try to get the x's together first. These cancel out. What's left on the left-hand side?
24.
24, very good. On the other side, 6x minus 2x. Let's hurry through the rest of this right here. What do we do next? Minus 12 minus 12. That gives me 12 on this side equals 4x. Those cancel out. What's the last step? Divide by 4. What's x equal? Is that our answer?
No.
No? What they ask us to find?
XC.
So they ask us to find the value of x, so we got half our answer. And they also ask us to find the length of segment xz. Where's xz at?
It's the full length of the line.
It's the whole thing here. Could we do this? If I plug 3 in there, that's going to work. But maybe I don't remember on my multiplication table, and I don't remember this, what 6 times 3 is. Could I put 3 in up here? What's 2 times 3? Plus 5? So that segment from here to here is 11. What could you do with those two to get the whole thing? What's 19 plus 11?
30.
If I plugged it in down here and I did 6 times 3 is 18, plus 12, what do I get?
30.
Get the same answer either way, right? Do whichever way is easiest. Sometimes going back and doing it the other way is going to be easier, depending on the numbers and everything that's in it. Jump back on your computers. On your computer, example 4. Example 4, read that real quick. Take a minute and read it. Take a minute and try to remember some names. What's the first thing we're going to do on this? Draw a picture. Now, they gave you a picture. Whenever they give you a picture like that one, is that really what you want to deal with? Why not? It's too complicated. Even though you can write in these books and everything, and that problem's right there in the book, it's too complicated. And I guarantee you, nothing against you, Josh, but when you're looking at that picture, your mind's going everywhere else other than on the problem. Oh, I wonder if there's anybody in the observation deck. Oh, I wonder if anybody's ever jumped off of that. Oh, I wonder if, all these things going through your mind, and you're not thinking about the problem. So this is my Space Needle. And this is what I would do if I was you. That's my Space Needle. Now, the bad thing with this one is, everything else we've been doing, been going left to right. It's going up and down. Is that really going to change anything? What's the first thing they tell us about this?
605 feet.
So the whole thing, 605. So from the ground to the very tip top.
Well, it says to the observation deck.
To the observation deck, 605?
I lied.
Total height of the Space Needle is 605 feet.
I lied.
So the total height. All right, so we got that. What else they tell us?
The height from the ground level to the observation deck is 10 feet more.
All right, slow down, because I'm getting confused already. So we got an observation deck somewhere on here, right?
Yes.
So we got our 2 points. That's probably going to be our third point, isn't it?
Yeah.
So let's put it on here somewhere. All right, now let's go.
It is 10 times, well, it's 10 feet more than 6 times the distance from the observation deck to the top of the Space Needle.
Oh, now I'm really confused. So they're telling us this is 10 feet more than 6 times
Like that.
this distance. Bad thing is we don't know this distance. When you don't know something, doing algebra, what do you put in?
X.
So what's the length from here to here?
X.
So let's make that x. Now this is going to make more sense.
Yes.
So from here to here,
It's 10 feet more than 6 times X.
so 10 feet more than 6 times x. How are we going to write that?
6x plus
6x plus 10, or 10 plus 6x, makes no difference. Does that look like the problems we've been doing now? Yeah, it looks the same, right? Looks the same, except it's sideways. What's our equation going to be?
6x plus 10 plus x is equal to 605.
Everybody agree with that? This plus this equals the whole thing.
So, combine like terms, be 7x plus 10 plus 605.
Everybody agree with Keaton so far?
Yeah. You subtract 10, it'll be 7x plus 595.
7x what?
Plus 595. Well, equals 595, sorry.
5 both sides by 7. Somebody grab their calculator. Next week when I say that, everybody's going to be able to grab their calculator, right? 80? 86? Again, what did I just say about if you have a calculator there? If you have a calculator, Keaton's there with the calculator and he's guessing.
Well, I wanted the 80.
I understand you, that's good, but you don't have to tell everybody when you say, okay, I think it's about this. 85? What's 85?
It's 85 feet from,
That's good, Chase.
it's 85 feet from the observation deck within the Space Needle.
So, and that's what you need to remember. Whenever we're doing these problems, we're actually doing something real world. Don't tell me x is 85. When you read that paragraph, was there an x in there anywhere? No. X isn't 85. We made up x. All right? 85 is the distance from here, from the very tip top, to the observation deck. Is that the answer they wanted?
No, we get played with.
What they want?
They wanted to just hide some ground to observation
So,
deck.
Daryl is standing here, right?
Yes.
He wants to know how far he is off the ground.
Oh, 85 times 6.
Now, if I do this, if I plug in 85 right there, 6 times 85 plus 10. Notice, Keaton's grabbing his calculator. I wouldn't have grabbed my calculator here. There's an easier way. What is it? Take 605 and subtract off what? 85. Isn't that easier than plugging this in and doing that hard multiplication there? Probably so. What is it?
5.
So how far is Daryl off the ground?
520.
520 feet.
Is it safe?
I think.
Yeah, it's 6.
520 feet.
That's a lot. You definitely splat.
Think? On your notes, fill this in. Fill in the parts you need to fill in on this. Last thing here. Yeah. I think there's one more thing we're going to do on. On this, do this for me. Congruent. Put a big asterisk out next to it. Very important. If you don't know what congruent means after about the first month of the school year, we may have major problems. Because we're going to say it so many times every day, you're going to get annoyed with it. Congruent. All it means, having the same measure. This is the symbol for congruent. It's an equal sign with a little tilde above it. That's a tilde, yeah. So like when you go to Spanish class and you have something like that, it's a tilde over an N or whatever. If we're trying to say two segments have the same measure, then we say something like segment NT is congruent to segment BL. That's telling you those two segments are the same measure. Congruent is what we use in geometry. When you were in algebra, you used the what? It means the exact same thing, just two different ways to write it. Alright? So this is saying this segment's congruent to that segment. Another way that we could say it is without the symbols and say segment AB is equal to segment CD. Probably not. Well, if it's this, then yes. If I want you to say that they're congruent, then I want that congruent symbol in there. Alright? Am I going to throw a big fit if you put a congruent symbol down here and don't put the symbols? Probably not. Okay, but for this, yes, I want you to start using the congruent symbol. Mathematically, it's incorrect if you mix those two together. I'm not a big stickler on, but if you're just trying to say they're congruent, then you need to know that congruent symbol. So we have that. Congruent segments. If I know that these two segments are the same length, the way I mark it in a picture is just by putting the same markings on it. So that tells me that those two segments are the same. Sometimes you'll see it and they'll have two. Well, if they both have two on it, then you know that they're congruent. You might see two segments. Maybe it looks like this. You got one segment there, you got another segment there, and maybe they put some silly mark like that on it. Guess what that tells you about those two segments? They're congruent. They're the same measure. So any things that are marked the same are congruent. Same measure. Example 5, look on your computer. Example 5. We're about done.
Example or extra
Example. Go to example 5.
Starts at 2:05.
There it is.
Does it look like this? Is that right?
Yep.
So we're looking at this. What's that tell us about this segment and this segment? They're congruent. Does everybody see that? So from P to Q is the same length as Q to R. Alright? This is a little different. All the ones that we've been doing up till now, we've been saying, and you got to be able to do these, because I'm not going to give you all just the same things. Everything up till now, we've been saying this plus this equals the whole thing. Did they tell us the whole thing this time? So now, we know that these two are the same length. What do you know about this length and this length? They're congruent. And if we're going to change it into algebra, instead of saying congruent, we're going to say they're what to each other?
Equal.
They're equal. So can we set up an equation from that? Give me one of the segments.
6x plus 20.
And we know that that has to equal what?
2, and parentheses x plus 6.
Does everybody see that? How that's a little different. Sometimes you'll get pictures like this, and you set up that equation that we've been doing. Sometimes it'll be like this. You got to be able to pick that out. Not everything's going to always be exactly the same. Scroll down, and we're going to do this part together, just because I know a lot of the problems on in the course test does different things like this. We're just going to drag and drop, and we're given a reason. What did we do to go from one step to the next thing? All right? In geometry, unlike in algebra, you just did stuff and it just got done, right? When we were solving equations, you just did it. My teacher told me to subtract 20 on both sides. My teacher told me to subtract 2x on both sides. You didn't really give a reason. Geometry, you got to give a reason for everything you do. How do we know that segment PQ was equal to segment QR? When we said two things are congruent, we said that means that they're equal. So drag that and drop it right in there. I missed my box. How do we go from that first one, PQ equals QR, to that next thing? Huh? Substitution? What'd you know about PQ? It was what? 6x plus 20. So you took out PQ and you stuck what in its place? 6x plus 20. Alright? Tonight at the game, Josh is in the game, and they take him out, they substitute in something of equal value, right? That's the way it's supposed to be. That's all substitution is. So we drag this down, that's the next one. How'd you go from this step to this step? Everybody agree with that? Distribute out? What do we do next? Subtract the 2x from each side. Everybody agree with Keaton on that one? Subtract 20 from each side. Divide each side by 4. Everybody agree with that? Go down there and check your answer. See if you got it right. Did we do it right? Now, the other thing that I want to mention on this. X came out to be -2. Is that okay? Can X be a -2? So if I'm standing here and I do this, did I go -2 steps? Is there any such thing as -2 steps? No. When you're driving your car and you drive it backwards, does it take miles off the odometer? No. Only a goofball thinks that, right? Doesn't take miles off the odometer, you're driving backwards. So you can't say, oh, I'm selling my car, and for the next 3 days you drive it backwards around town so that it's got less mileage on it and you get more money. It doesn't work. All right? John back there thinks it works. He's the Ferris Bueller of National Trail, because have you ever seen Ferris Bueller's Day Off? And what they do? They jacked up the car on jacks and put it in reverse and ran it backwards and let it sit there running backwards, thinking it was taking miles off the odometer so that they wouldn't get in trouble. So you can't have a negative distance, but if I stick -2 in there for X, what's 6 times -2? What's -12 plus 20? How long is segment PQ? 8. Is that okay? So X could be negative as long as the distances aren't negative. Now we're done with the computers. In your notes, did you guys understand all that? All right, let's quit.
That was a lot.
That's your assignment. It's on the back of your notes. So make sure that you do it. Get a calculator, get a binder, make sure you get that.